Right, so we're going to go through the last AS test. We'll start with the first question, which is arguably the hardest question. So we are basically we're told that this curve y equals x squared minus 2x plus 3 never intersects this line. And we're asked to find the range of k values in surd form that mean that this never intersects this curve. So I've plotted both of these on GeoGebra. So you can see here's our quadratic, here's our line, and if I alter the k values, which you'll see is the gradient of this line, we can see some k values mean they intersect and some mean they don't, and then on this side some mean they intersect, some mean they don't. So those are hopefully going to be the k values that we can find by solving this question. Okay, so what we're going to do, if they intersect, it means there's a solution to their simultaneous equation. So I'm going to set these two equal to each other. And the theoretical solutions to this would be where the line and the curve meet. So if I rearrange this and turn it into a quadratic, get it all on one side. So we'll have x squared minus 2x minus kx plus 3 equals 0. And if there's no solutions to this, then the discriminant of this, b squared minus 4ac, will be less than 0. So if there's no roots to this, they never intersect, which means that our discriminant should be negative for this. So most of you got that. I think the bit people missed out was that b is the x term. So if we just have a quick look again at quadratics, so ax squared plus bx plus c equals 0. A is the thing times by x squared. It's the coefficient of x squared. So in this case, a is 1. B is the coefficient of x. Now we've got two different x terms. So what we need to do is factorize out plus x. So this term can be rewritten as plus x, plus x. So we got minus 2 when we factorize x out of this bit. And we got minus k when we factorize x out of this bit. So we got x squared plus x times minus 2k minus 2 minus k plus 3. So b in our quadratic equation is minus 2 minus k, and c is going to be 3. So I think what most people did wrong was they thought that kx was part of c and not part of the x term, although it has an x next to it. So a, b, and c, these are coefficients. A is the x squared coefficient, b is the x coefficient, in this case it's two different things, and c is the no x term on the end. So put these into our discriminant equation. So we're going to get b squared minus 4ac is less than 0. So that's going to be minus 2 minus k all squared. So that's our b term. Minus 4 lots of ac. So 4 times 1 times 3 should be less than 0. So we'll expand this. We'll solve this quadratic. Do a quick sketch. We could use a calculator for that too. And then we should be able to get our range of k values. So expanding this thing, we are going to get 4 plus 4k plus k squared, and here we're going to get minus 12. So less than 0. So if I simplify this bit, we've got k squared plus 4k minus 8 is less than 0. Now we could sketch this discriminant and try and find the roots, or we could use a calculator. So let's have a look at this one. So go on to the inequality solver, which is this one. Polynomial degree, or we've got a quadratic, so it's going to be degree 2. And although we don't have x, we've got k. We can, we're using x instead of k on the calculator, so it's less than 0. So that's going to be option 2 on this list. So put in x, or put in the a. So a is 1, b is 4, and c is minus 8. And there we go. So our solutions is going to be k is less than minus 2 plus 2 root 3. And then minus 2 root 3. Now you could solve that with the quadratic formula, but it's a lot quicker just to use a calculator. So that is the range of k values that mean that this line and this curve never intersect. Cool. All right, on to question 2, which was on transformations. So yeah, basically we got a cubic. Not the best, well, it's drawn there anyway. So we've got a cubic with point 23, minus 23, point A, and B, which is 5, minus 5. And then we've got two transformations. So the first transformation, A wants us to find f of x minus 2, so where these points end up. And the other one is asking us to find 3f of 2x. So for the first one, we've got a horizontal translation of plus 2, because remember, x transformations do the opposite. So we're going to move all these points to the right by 2, plus 2 in the x direction. So this point is going to become 0, 3. And this point is going to become 7, minus 5. Yes. Okay, forget that. This point was actually 3 minus 5, so it becomes 5 minus 5. So be careful when you're copying your points. They are quite small on this test. Cool, so that's the first one. The second one, a bit more difficult. We've actually got two different transformations going on here. So the first transformation, this is outside the function, so it is going to be a vertical transformation, and it's times by 3, so you're going to stretch y by a factor of 3. And the other one is inside the function, so it's going to be a horizontal transformation, and again it's multiplying, so we're going to stretch x by, and again it's the opposite, so it's going to be stretch x by a half. So a lot of you got this wrong and you just multiplied x by 2, remember inside affects x and it does the opposite. So we've got to go back to our original points, so that was minus 2, 3 and 3 minus 5. So our first point, so let's stretch y by 3 first of all, so that 3 is going to become a 9. So we'll get 9 as our y coordinate, and our x coordinate, we've got to half it. So it was minus 2. If we half minus 2, we get minus 1. So that's where A ends up. B is 3 minus 5. So again, stretch the y by 3. So we're going to get minus 15 as our y coordinate. And our x coordinate, we've got to half it. So we're going to get 3 over 2, or 1.5. Cool, so that was worth 4 marks. Next bit of the question asks us to sketch the gradient function. So we have to ask ourselves what the gradient's going to be. We don't have the original function, so we're going to need to just look at the sketch we've got and use that to work out the gradient. So if I make a bit of blank paper. So at the moment we've got, so that point is 3 minus 5 and minus 2, 3. There we go. So we've got what looks like a positive gradient up to this turning point at x equals minus 2. Then we've got a negative gradient until x equals 3. And then we've got a positive gradient again. And our turning points are at 3 and minus 2. So x equals minus 3, the gradient is 0, and at x equals plus 3, and at x equals minus 2, the gradient is 0. So it's a cubic. If we differentiate a cubic, you know we're going to get a quadratic. So we've got a quadratic with a root at 3 and a root at minus 2. And if we look, we're going to start off with a positive gradient, so it's got to be positive when x is less than minus 2, so this bit's got to be positive. We've got another positive bit when x is greater than 3, so that's this bit. So anything greater than 3, dy dx must be positive. And in the middle, we've got a gradient that goes from 0, negative, and then back to 0. So from 0, negative, back to 0. So there is our gradient function. We can label that f dash x, or dy dx, and then x on the x-axis. Cool, last bit. State the range of values for which it's a decreasing function. So decreasing when dy by dx is less than or equal to 0. So a lot of you forgot the equals to bit there. So decreasing is going to be when the dy dx, so if you look, here's dy dx, is less than or equal to 0. So that's all of this bit here. So it's going to have a negative gradient when x is greater than or equal to minus 2 and less than or equal to 3. and outside these ranges will obviously be increasing. Cool. All right. Next one, question 3. So this is our circle geometry question. So we got 2 points, A, which is 5 minus 1, and B, which is 13, 11. We're first of all asked to find the midpoint. So midpoint, as most of you remembered, actually is the average of the x's, average of the y's. So it's x1 plus x2 over 2, y1 plus y2 over 2. Remember, x first, followed by y. So just make sure you get the x's in the right place, the y's in the right place. So for the first one, it's going to be 5 plus 13 over 2, and then the y coordinate is going to be minus 1 plus 11 over 2, which gives us 18 over 2, and 10 over 2, in other words, 9, 5. So that was worth, just 1 mark for that. So just 1 mark to remember the equation and work it out. Next bit is asking us to find the radius. So radius, if these 2 points form the diameter, it's going to be the length of half the way between these 2 points for the radius. So part B is find, actually we need to, given AB is the diameter, find the equation of the circle. So we need the radius and then we need the midpoint. So radius, first we'll find the diameter. So diameter equals square root, the difference in the x's squared plus the difference in the y squared. So x2 minus x1 squared plus y2 minus y1 squared. So if we put everything into that, we're going to get diameter equals the square root of 13 take 5 plus 11 minus 1, which is going to be plus 1. So make sure, again, minus and minus, you've got to be careful with these things. 13 take 5, 11 minus 1, so plus 1. Cool, and if we work that out, we're going to get the square root of, that's going to be 8 plus 12 squared. Which is going to give us a square root of 208, which if we simplify using surds, we're going to get 4 root 13. So diameter is 4 root 13. So this is another bit where people went wrong. Remember, the radius is half the diameter. So always label what you're finding when you're doing this. So the radius is going to be 2 root 13. So I put this into our circle equation. Remember, it's x minus a squared plus y minus b squared equals r squared. So we get x minus 9 squared plus y minus 5 squared equals the radius squared. Don't just write the radius. So we need to do 2 root 13 all squared. Get calculator out. And you get 52. So we get x minus 9 squared plus y minus 5 squared equals 52. So it's 1 mark for getting the centre in the right place and 1 mark for getting the radius squared properly. All right, next question. So where are we up to? So for the next one, we need to do some shading of inequalities. So if I do some axes and we'll work out what all these things look like. So we've got to have y as less than 4 minus x, x plus 1, y is greater than 4 minus 2x, and y is greater than 1. Alright, so we'll start with the easy one, which is just y is greater than 1. So find 1 on the y-axis. Some of you did this on the x-axis. No, y-x. So y greater than 1, or y is going to be this coordinate for 1. So, and we're talking greater than here, not greater than or equal to. So it has to be a dotted line, remember. Dotted for not including. So there we go. Next one is this one, so y is greater than 4 minus 2x. So we've got a line here, just a line equation, y equals 4 minus 2x. Negative 2 gradient, so if you imagine negative 1 gradient, negative 2 gradient is slightly steeper, and then it should pass through at y equals 4. So something like this. And again, it's not including, so it's not equal to, it's only greater than. So again, put the 0.4 in there. There's our line. Okay, so last bit is the quadratic. So we're told the roots. We know one root is positive 4. The other root is minus 1. And the other trick is this is a negative quadratic. If you expand this, you get minus x squared. So it's giving me one of those unhappy faces. It crosses the y-axis at 4, so it's going to go through this point. So something like this. And again, it is less than, so we need to have a dotted line. So we get something like this. So let's just look through all these and see which region we need to sketch. Some of you got all the lines in but sketched or shaded in the wrong region. So it's got to be greater than 1. So that's all this stuff is possible. It's got to be greater than 4 minus 2x, so it's above this line. So all this stuff is possible. And it's got to be less than our quadratic. So that only leaves that region. Cool, and that was worth 4 marks, 1 for each line by the looks of it, and the correct region. Next up, binomial expansion. So you just got to learn this. It's a bit tedious, but it will come up year in, year out. So we've got to expand up to the first 3 terms of 2 minus 3x to the power 6. Cool, so we'll do this with the NCR method. So we're going to get 6c0, 2 to the 6, plus 6c1, 2 to the 5 times minus 3x. Be careful of your brackets, that's where most of the marks got lost. 6c2, 2 to the 4 minus 3x squared, and wait, 1, 2, 3, yeah, that's first 3 times. Cool, so stop there. So get calculator ready to work out these combinations. I happen to remember 6c0 is always 1, so we just got 2 to the power 6, which is 64, of course. 6c1 is going to be 6, so let's get all this ready on the calculator. So 6 times by 2 to the power 5, 192, times by 3, 576. And if you look, it's minus overall, so minus 576x. Cool, alright, last term then. So 6c2 again, type it into the calculator, and we get 15 times by 2 to the power 4, which gives us 240. And then we need to times this by minus 3x squared. So minus squared, it's going to be a positive. And then we've got to times this by 3 squared, so times by 9. So we get 2160x to the power 2. So just take your time with those. They're easy, but you've got to be confident in what you're doing and slow so you don't muck up your brackets, your minus signs, or your squaring stuff. Cool, so that was 4 marks. Next bit is a bit of first principles differentiation to show that the differential of 4x squared is 8x. So remember the equation for this is f dash x equals f of x plus h minus f of x over h. So f of x is 4x squared. F of x plus h. Remember, we're going to replace all the x's with x plus h in brackets. So we get 4 brackets x plus h. If you're ever in doubt for that, just find your original function, all the x's, just brackets right around them as close as you can to the x. That's the thing you replace with x plus h. So then subtract 4x squared, which is f of x, and divide by h. So all we've got to do is expand this, subtract that, divide by h, say it goes to 0, and then we're done. So if we do this properly and expand the quadratic x squared plus 2x hx plus h squared, so you can use binomial expansion on that if you want to do it quite quickly. It's good with the cubics as well. Minus 4x squared all over h. Next line, we'll expand it all, so we get 4x squared plus 8hx plus 4h squared minus 4x squared over h. Be careful with the expansions. Some of you got this term wrong and you had 4 instead, which would lose a mark. So all we need to do now, these two terms, 4x squared minus 4x squared, they cancel out, and then we can divide all this by h. So we get f dash of x equals 8x plus 4h. Now we've got right down to the last bit. We're just going to say h is really small, so it tends, not towards infinity, it tends towards 0. So this becomes f dash x equals 8. x, which is the proof you need. So make sure you got all these steps, make sure you include h tends towards 0 and your final answer, because it is a proof after all. All right, what's next? We got some e's and luns and logs. So yeah, these again just require a bit of practice. So we've got to solve a few equations. First one, we need to solve 3 to the x equals 45. So a couple ways you can do this, I'll go through both. We could log both sides. We get log of 3 to the x equals log 45. Remember, when I don't write a base, I mean base 10. Then we use the power rule, x log 3 equals log 45. And then we can divide through to get x equals log 45 over log 3. Which gives us 3.465. Cool. Right, the other way you can do it is by writing it from exponential form into log form. So we get log base 3 of 45. It's x, which you just type in log base 3, 45. And of course you get exactly the same thing. X equals 3.465. Cool, alright, that's the easiest one. Next one, I think, was the one that had the most trouble. So B is log base 3, 4x plus 1 minus log base 3 of x equals log base 3 of 7. So the trick here is to use log rules to combine them all, turn it down into one log from exponential form, and then solve it. So we're going to use the division rule first because we've got two logs being subtracted. So we get log base 3, 4x plus 1 over x. Cool. That equals log base 3 of 7. Now, because this was a lot of people missed, if you got log of something equals log of something, and the base is the same, we can just say, well, for this to be equal to this, the things inside the logs must be equal. So we can effectively just cancel out the logs. We're not really dividing, definitely not dividing by logs, we're just unlogging each side. So we end up with 4x plus 1 over x equals 7, times up by x to get 4x plus 1 is 7x, take away 4x from each side, 1 equals 3x, so x equals 1 third. Cool, alright, on to part C. So here we're asked to solve e to the 3x minus 1 equals 17. So, that would write that bit weird. Let's do that again. E to the 3x minus 1 equals 17. Okay, so we're going to lun both sides, basically. It's the only way to get rid of e. So by lunning this side, the lun and the e cancel, we get 3x minus 1. And we've got to lun this side, don't forget, so we get lun 17. Now we can add 1 to each side. 3x equals log 17 plus 1, should be in brackets, divide by 3. X equals ln 17 plus 1 over 3, and you can work out what that is if you like, but I think I'll just leave it. Okay, next bit, part D. So we've got 3 ln of 2x plus 1 equals 7. And the temptation here is just to e both sides. Kind of like we did here, we learned both sides. You can't do that while the 3 is there. You can, but it becomes a lot more difficult when you have to use log rules. So we're going to divide both sides by 3 first of all. And that's the key to these, divide first. So ln of 2x plus 1 equals 7 over 3. Now we just have ln equals this. Now we can e both sides. So e of this turns into 2x plus 1. And e of this turns into e to the 7 over 3. A lot of you got a bit mixed up and you kind of wrote e learn and then you forgot if you'd e or learned it, so you learned there, it became a mess. So just be really careful, e this and it gets rid of the learn equals e to the power of that. So now we subtract 1, so 2x equals e to the 7 over 3 minus 1, and then divide by 2. X equals e to the 7 over 3 minus 1 over 2 in exact form. Good. Alright, what's next? Another exponentials question, which was pretty easy if you knew what you were doing with it. So, yeah, we've got radioactive mass of a substance is decaying such that after T days we've got this equation. So M equals 40 plus 300 e to the minus 0.002 T. So part A is the initial value. So to use some physics notation, we'll have m naught. Part B wants us to find mass after 80 days. Part C wants mass below 150 grams. T. And for part D, we want to find the long-term mass. Cool, so first bit, initial mass. Initial means T equals 0, so T is 0 at the beginning. And this initial anything, you can generally say T is 0. So we're going to put T equals 0 into this equation and find out what M equals. So we get M equals 40 plus 300 e to the power 0. E to the power 0 is obviously 1, so we get 1 times 300, so we get the mass is 340 grams. So easy if you know what you're doing. Some of you mocked up putting 0 in and you got like 0 for this, so you end up with 40. But it is 340 grams because e to the 0 is just 1. Okay, next bit, the mass after 80 days. So we're going to put 80 into this equation. So we get M equals 40 plus 300 e to the minus 0.002 times 80. So bung it in the calculator. 40 plus 300 e to the power minus 0.002 times 80. And you get 295.64. So we can round that up. Well, we don't really need to. So 295.6 grams is the mass after 80 days. So it's decayed a bit there. Next bit, when does the mass fall below 150? So we're going to say 150 is the mass we want to fall below. So we can have that is more than 40 plus 300 e to the minus 0.02 t. Right, so we just got to rearrange this to find t. So first of all, we're going to subtract 40 to get 110 is greater than 300 e to the minus 0.002 t. I forgot all there. Now we can divide by 300, so we get 11 over 30 is greater than e to the minus 0.002 t. Now we want to learn both sides because we just got e on its own, so we get log of 11 over 30 needs to be more than minus 0.002 t. And we're going to divide both sides by minus 0.002, so ln of 11 over 30 over minus 0.002. Now, we divided an inequality by a negative, and if you divide all times an inequality by a negative, you have to change the inequality around. So we get is less than t. So the first day, or the if it wants time, we can just give a time. If it wants the first day, it falls below that. T is going to be the first day after this number. So we type this into a calculator, we get log of 11 over 30 divided by minus 0.002, and we get t is greater than, t is greater than 501.65. So the first, 501.65. So the first day it becomes less than 150 grams, t is going to be 502. So either answer there is really acceptable. Cool, last bit was the long-term mass of the substance. So here's our equation. Long-term, we can imagine putting a big number of t in here. Now, I've said to some of you, put in a big number of t. Problem here is we've got a very small number before t. So unless you put in a really big number for t, this made it less big and then it didn't have the same effect. So we can put in t as 1,000, that might do the job. So we get 40 plus 300 e, 40 plus 300 e to the power minus 0.002 times 1,000. And yeah, it doesn't quite work. We need to pick a bigger number. So if I put in 10,000 or a million instead, the mass goes to 40. So yeah, for some of you, it was kind of my fault because I should have said put in a much bigger t value, but here we get 40. The reason why it does that though, if you think of what this looks like, we got an exponential to a minus power of x. So that's going to look like this. If you imagine the rest of the graph, it's been moved up by 40, so the asymptote for this is now at 40, and we said the initial value was at 340, so this is 340. So this is what the graph of our radioactive particle looks like, or radioactive substance looks like. So it's decaying, it's becoming less, the mass is decaying, and when time goes to a really big number, we get to 40. Problem is, because this was so small, if you put in 100, you were still getting a value that wasn't quite at 40 yet, so you needed a really big value. All you needed to know, e to a minus big value is always going to tend towards the asymptote at 40. So a quick sketch would have sorted it out, but just be careful with those. If this is small, your t value needs to be huge to get the same effect. So long-term mass is 40 grams. Right, on to the last question, which was differentiation, turning points, dy dx, and minimums and maximums. So we were given the equation y equals 4x squared plus 5x minus 1 over x. So A, we want to find the gradient function, dy dx, B, stationary point, and C, min or max. So, basically, first bit, dy dx, in order to differentiate this, we need to sort out this fraction here. So we're going to say y equals 4x squared plus, so we can split this into two fractions. 5x divided by x is going to give us 5, and minus 1 over x is going to be minus x to the power minus 1. Notice I have not differentiated anything. All I've done is simplify this bit into a form where we can differentiate. So label it y because you haven't differentiated. Now I'm going to differentiate, it's my next step. So 2 times 4 is 8, x to the power 1. 5 disappears when you differentiate it because it's just a number. And this one, minus times a minus, is going to give us plus x. Take 1 from the power to the power minus 2. So that's a differential. I think you got 1 mark for that bit, 1 mark for that bit, and 1 mark for rewriting y. Stationary point, well, that's when the gradient is 0. So dy dx equals 0. So you got 1 mark for setting this equal to 0. 8x plus x to the minus 2 equals 0. And now we need to solve this. Solving these is difficult because the minus 2 kind of puts you off, but to do that, let's rewrite this the same way that we wrote 1 over x as x to the minus 1. We're going to do the same with x to the minus 2. It's just going to be 1 over x squared. So 8x plus 1 over x squared equals 0. That seems easier to solve, so times it all through by x squared, so we get 8x cubed plus 1 equals 0. Subtract 1, so 8x cubed equals 1. Minus 1. Divide by 8, x cubed is minus 1 over 8, and then cube root that, and you get x is minus 1 over 2. So the stationary point x coordinate is minus 1 over 2. We need the y coordinate too. So if we put that back into our function, we get 8 times minus 0.5 plus minus 0.5 to the power minus 2. Which gives us the y value of, I put it in the wrong equation. Make sure you put it into the y equation. So 4 lots of minus 0.5 squared, sorry it's taken ages guys, I'll edit this out, plus 5 lots of just plus 5, plus or minus 0.5 to the power minus 1. So you should get y equals 8. Cool. Right, last bit. Find the if it's a minimum or maximum. So minimum maximum, to check that, we need to look at the second derivative, so d2y by dx squared. And so we're going to differentiate this equation again. So 8x differentiates to give us 8, and this one's going to be minus 2x to the minus 3. So there's a second derivative. So I'm going to put in the point x is minus a half. So we get d2y by dx squared equals 8 minus 2 times minus a half to the power minus 3. So again, get the calculator out. You could do it by hand if you want to actually. So 8 minus 2 lots of minus 0.5 to the power minus 3, which gives us d2y by dx squared equals 24, and 24 is greater than 0, therefore it is a minimum. minimum point. Cool, I think that's the whole test then. So hopefully that clears up any issues anyone has. Yeah, thanks guys.